All right, I appreciate the patience here. Gonna have a couple seconds here delay. Got some stranglers coming in. Does this look right? Just a pilot. Oh yeah. Oh cool. Out of where? Concord? Charlotte? Oh shoot. Okay, so yeah, the big stuff. Wow. We'll have to talk later. All right, the light's green, which means I'm talking. Howdy, everybody. We're going to be talking about Terraform today. This is kind of aimed at anybody who knows what Terraform is but has never used it. Maybe a lot of people around them use it. Maybe they just don't really know what it is, right? This is like not an advanced class. Obviously, it's 101. It's very elementary. We're going to be talking about basically how to just get some hands-on exposure to it and some things that you don't want to do once you've started using it. So I'm James Thomas. I work for Cruise, the robot car company. If you're not familiar with us, we're kind of like Waymo, but better. I worked at a bank for 6 years before that, and thankfully I got out. So I know a whole lot about ancient garbage architecture and modern sleek architecture at the same time, and a lot of home lab stuff, and Terraform kind of applies to all of those. We're going to be going through Terraform. We're going to be trying to convince you that you need to use it. If I've succeeded in that, we're going to be talking about scaling, Terraform for teams, cloud, CI/CD, all that kind of good stuff, and a couple of pitfalls and things you should not do with Terraform. All right, so what is Terraform? People kind of think that it's like Ansible or like bash scripting or something like that, but not really. Well, it is like Ansible, but it's not like bash scripting. You'll see the syntax later, and it'll make a lot of sense, but Terraform is a declarative way to define configuration for your infrastructure. So you say, I want a VM to exist. You put that down as a config that looks kind of like a JSON object, and Terraform just makes it happen no matter what. If it's not there, it'll spawn it. If it is there, it'll make sure that the configuration is correct, that kind of stuff. The important part about this is it's on code, right? So you can check it into Git. You can have people PR, that kind of stuff. So instead of saying, oh, I want a Jira ticket, and then SRE's got to go figure that out and click a bunch of buttons in the UI, and then we forget who did it, it's all just in code. You have a reference, a hard reference to why it got there, who put it there, who approved it. You now have an approval process for the clicking buttons part. And you no longer have to click the buttons, therefore click the wrong buttons by accident, which we've all done. This is what it looks like. So you see that resource object over there on the left. Very simple. I mean, this is like, that's the whole thing. There's just a lot of those. So you can see I have like my virtual machine, a machine type. This is for GCP. If you're using Proxmox, it'd look very similar, but it'd be Proxmoxy. Same thing for ESXi or whatever, AWS. Don't care. The beauty of Terraform is that it works for all cloud providers and self-hosted bare metal type stuff. Like there are plugins and providers for all of it. HashiCorp developed this in 2014, and they had two plugins for it, two provider plugins, AWS and DigitalOcean, and then they said, look, it works, everybody come on in. And after a couple of years, it started to get traction, and then Google said, fine, we'll publish our Terraform suite, and everybody else kind of like decided to jump on board. And now it's like an industry standard, an inescapable black hole that you must conform to and will hate if you don't like it, unless you do a little bit of work beforehand to get comfortable with it before you're suddenly in a 10, 20,000 line Terraform monorepo. HCL, why HCL? So this looks kind of like JSON, but no commas, and it looks a little confusing. And why another language, right? Probably the same reason Yara or YAML exists. You can do a little bit more with it. This actually translates to JSON. You can technically convert this to JSON. You'll see in the next slide, and you can convert JSON to this. But see that ternary operator there? So you get very limited logic. This is not coding. It is not functional. You don't get to say if this, then that. But you can do some little resolution type stuff here, which is important because sometimes you want environment variables to influence the config. So maybe you have a VM, and you're like, yeah, if it's in prod, I want it to be massive. And if it's in dev, I just want a little micro for testing, right? This lets you do that in a very clean way that's easy to follow. HCL is also like super standard and very mature and supported. So let's do this. We're going to do a little bit of hands-on of what it actually looks like. So I'm going to come in here in a very basic Terraform, very, very basic. I mean, there's nothing here except for the fact that I have what's called a provider, which is, again, that plugin that says I know how to interact with Google resources via this HCL config. I have a project called Terraform Self 2023 that I spun up, and I'm going to put all my stuff in US East 1. For the sake of this, you can very much configure all this stuff however you want, but this is a very basic example. And here, I'm going to spin up a GCS bucket. It's like an S3 bucket. If you're not familiar with that, this might not be the talk for you, but just a folder on the internet. I'm going to have a couple of configuration options here. There's a ton. I mean, I could go down the rabbit hole with things that you can do here. And if you look at the docs, which we'll look at in a minute, I mean, it kind of lays everything out in a very clean and easy to follow way. Also, you can just Google it. Like, if you just take any of these and Google them, you'll see a million Stack Overflow references of how to do different types of things with this. But in this case, I'm going to spin up a GCS bucket. So what this looks like here, let's say I'll go into basics. So there's nothing but main.tf here. There's no other magic sauce or anything, right? I'm going to run Terraform apply. You may have seen this before, or Terraform plan, right? And it's going to throw an error. You have to init first. So there's an issue. It doesn't know what I'm talking about. It doesn't know these dependencies, right? So you always start with Terraform init on a brand new repo, or if you've cloned a repo down and you want to work with it with the CLI. So now I've initialized it. It's done a couple things here. It's given me a lock file. This is a lock file very similar to like a Node package lock file, Python lock file, whatever you want there, right? It's also downloaded and cached the provider package itself. This ends up being packaged for you, but you can go on GitHub and you can see the provider file and see the API calls this makes on the back end. And again, all this does is it literally just makes API calls against GCP's resource API for you. It just translates all of that. So instead of you having to write it out in Python or Bash or whatever, you can just have this nice config there. So now I can run Terraform plan, and I'm running TF here. That's just an alias to make it so I don't have to type so much stuff. And it's gonna do a couple things. One, it generated a state file because I didn't have a state file before. That state file is going to look at actually it doesn't because there's nothing on state right now, but you can see I have one to add, which is this resource. It's reached out to GCP and it's like, hey, do you have a bucket that's called this? The answer was no. So it's telling you, well, if you want to execute this is what I'm going to do. I'm going to create this bucket for you. It's going to have these required attributes. All of these resource modules have a set of required attributes that you have to have. These are some outputs too. You'll see the storage class and the public access prevention, stuff like that. Right. After you apply, it's going to get that response from the API, and it's going to set it in your state file, which we'll see. So I'll run Terraform apply. Fun fact, everybody usually runs Terraform plan and then Terraform apply. Terraform apply literally runs the same code as Terraform plan before you enter yes, so you don't have to run Terraform apply ever if you're doing this locally. It does give you a --out flag if you run tf plan, and then you can pipe that to a file, which is like cool sometimes, but typically there's no point. And if anybody does know a reason, please tell me. Cool, so I ran Terraform apply, hit yes. You can see that it took like 2 seconds. It just reached up to the GCS or the GCP API and said, hey, make this bucket. API return 200, everything's good to go. Now we can look at our TF state. This is the brains of the operation. So this state file right here has everything in it. So you can see resources, I've got an array, and I've got just one thing in the array, and that's that bucket that we just created. So it's a Google Storage bucket. There's the name of the module, right? So example GCS bucket. The name of the actual bucket is going to be in the resource. So instances, this is an array. You can actually spawn many. So you can say, hey, for this, I want count 10. If you wanted to spawn 10 of the same VM, right, or some policy, right, you can do that. In this case, there's just one, and it's that bucket that I created. And you get the nice, URL to the whole bucket too. So it knows this is what it got back from the API. There's your GS URL. So the whole thing is managed in state there. This is pretty cool because now if I run Terraform plan, it's going to take what I have in state and it's going to confirm that's actually what exists. And if so, no changes. Your infrastructure matches the configuration. You're good to go. This is cool because you're going to start appending more and more things here. And as you do, you don't want to keep trying to create that bucket every time, right? So this state file right here, for better or worse, kind of keeps track of that locally. We'll go back to the slides. like I talked about earlier, JSON technically is compatible. It's kind of jank. I tried to get this to work. I got it to work in a few cases. I mean, officially on their docs, it's like a first-class feature, but I would never use it. Maybe I could see a case where you might programmatically generate JSON and then try to convert it over, but all the conversion SDKs and plugins I found kind of suck, so I wouldn't rely on that. There's also other services that will help you generate this, and now with the TF SDK, I think. We were talking about this last night. You can generate this with Python, so you have like a layer on top of it that allows you to kind of intelligently generate a whole bunch of Terraform, which is great or scary, depending on how you see that. Cool, so you're like, yeah, I like Terraform, I like the idea of this, I'm cozying up to it, but I've got like 1,000 resources, right? And I'm in a production org, and I've got a bunch of VMs and all kinds of firewall policies, and I don't know about all this, right? How do you get that into Terraform? Sadly, there's no like magic, just click the button and it's in here. There are tools that help you kind of automatically generate that. So like in Microsoft, there's like a first-class tool they provide for Azure to like import resources and actually create all the beautiful config like this. Otherwise, you can manually create this config. So this bucket, if it didn't exist, you can run Terraform import against it, and it will look for this unique ID, right? Instead of creating it, it will say, does it exist? And then it will pull all the attributes down into state, and then it will map it to that resource name, and then you're good. Now it's managed. So if you have existing VMs and stuff, it's pretty easy to import them into Terraform, and now they're managed, and you didn't have to touch them or recreate them or anything like that. It's declarative, like I said earlier, which means it's not a set of instructions. This is not a bash or Perl script. This won't, like, if exists, then do this. I mean, it kind of does that on the back end, right? But the idea is that you define this state, kind of like Ansible. I want this to exist, and it magically does it for you. And by magically, I mean those providers have code that will reach out to the API, see if state is aligned, and if not, make those changes. This is cool because you don't have to worry about the long list of things that you might have to deal with, right? Let's say an attribute was updated. Google is going to publish an update to the provider. And then you'll be able to easily say, oh, okay, this one attribute and some API over here has changed. I now know about it. I don't have to worry about dealing with that. Also allows you to do very easy things like, I want to upgrade the RAM on this machine. Again, traditionally, you'd go in the UI, you'd shut down the machine, you'd try to do that or whatever, and then you'd have to bring it back up, and you've got downtime. Still, I mean, same things. You're just hitting the API to do it, but this kind of does it very, very quickly and seamlessly. So it's like as rapid as you can get for emulating clicking buttons on the UI. Terraform doesn't know or care about anything outside of state, right? So if you look in here, I've got this example GCS bucket. If I'd created, I don't know, 30 buckets before this, which I have a couple in here, you'll see in a minute, Terraform's not going to mess with that. It really only cares about anything that you've had here, and that's because when you run Terraform plan, it goes through all these resources and it does a look. It fetches on the API for that specific resource. So it's not going to touch anything that you're not managing with Terraform. So you can kind of use it in a partial manner with an existing environment and say, I just want to use Terraform for a couple things over here. That's cool. It's kind of recommended that you try to use Terraform for everything or nothing, though, because you don't want things in the UI that you don't know if they're managed by Terraform or whatever. And if you delete things in the UI, if you go and like delete a VM or delete a bucket and try to run Terraform plan, Terraform gets really confused. It doesn't account for that sometimes. Sometimes it does very beautifully, but typically once you adopt a Terraform pattern, you lock down the UI and you don't let people do changes in whatever environment Terraform's controlling. And sometimes that's just prod. It's a common pattern to say, look, sandbox, dev, do whatever you want, use the UI, we don't care. But then write your Terraform and PR that into prod, and that's controlled. We kind of went over Terraform state, so not a whole lot to see here. But again, instance attributes, you've got that bucket, and you've got all the things. It knows what it should be on remote, which is cool because if that changes, let's say I go into the UI and I do make a change, right? I change maybe the accessibility of this bucket and say I want it to be public. The next time that Terraform is ran on your repo, it's going to say, whoa, someone modified this. It needs to change back, and you'll see that modification request on there. So again, yeah, there's that old bucket. You can see that's the one that's managed. It's going to leave this one alone. Importing, that's what it looks like, so we talked about that. Literally, it's just Terraform import, the type of object that it is, the name of your module. So see this imported bucket here, and there's that. And then this is what the unique ID of it. So if it's a VM, it's going to be the instance ID. In this case, the bucket ID is unique. That is the unique identifier. So then it hits the API, pulls that in, saves it, and says, good, we're managed. So a lot of people see this and then they're like, yeah, okay, cool, but the UI is like, it works. I don't want to deal with all this. And that's cool. If you have like 6 VMs and 2 SREs, you really don't need Terraform. It would be good, but it's not going to like change your life. It's just going to be a neat tool. But when you start scaling, you're gonna really want it. So I really don't agree with the whole like the UI is just fine thing. That's kind of that's a very, I don't want to say junior way of thinking, but it doesn't scale very well, right? And if you're not going to scale, let's say you have a very small operation and you're only going to have like 50 resources, ever 100 resources, and you have tight control over it, and your org is small, that's cool. But when you start getting up there to 1,000, 10,000, 100,000 resources in a cloud provider, it's just too much. You can't do that in the UI. Like you need some tooling or scripting. It doesn't have to be Terraform, but you will need help at that point to make sure that everything isn't falling apart and what is there. So Terraform is one tool of many that can help you kind of wrangle that and manage it. And the earlier you implement it, the better, because you don't have to retrofit it into your stack. You also get like unified config across environments. I was talking about this earlier. So this is pretty cool. One of the pitfalls, I think I had this in a later slide, of Terraform is people have like a dev folder and a staging folder and a prod folder, and they'll like copy and paste their Terraform code and they'll slightly change some of the attributes. Don't do that. It's like the easy way out, and it makes sense when you're tinkering with Terraform, but you're going to have, again, the same thing with clicking buttons in the UI. Your environments are going to be so out of line because people are going to forget things or drop things because it's convenient, and they're going to they're going to do whatever they want, and all that code's going to be totally separate, and then your environments have no equality. They're just totally different and unpredictable, and then people won't use staging, right? So what you do want to do, use those environment variables. They're very helpful, and force it to work, right? So it's easy to say this doesn't work because we don't have this in prod, right? You can kind of account for that in Terraform. I'll show you later how. And that means that all your infrastructure is going to be the exact same, except for some configuration differences like VM memory size, that kind of stuff, right? Scaling, like I was talking about before, yeah, it scales. So we at an unmentioned org have like 32K resources managed by 800 plus Terraform workspaces in Terraform Enterprise. This segregation of resources to workspaces make it so that developing teams manage their Terraform stuff all by themselves, no help from SRE, and it's tightly contained, and we have a ton of Sentinel policy on top of it to make sure they don't do dangerous, stupid things. And it works great. Our PaaS system lets users click a button, get a namespace, get everything set up, and then they can do whatever they want, and it will have no impact on anything else. And they can use our shared resources, and they could submit PRs into our main GCP infra repo if they want to do like big org-wide infra changes. That's cool, because again, it's Terraform, so we can PR it, go back and forth, approve it, and then we have a machine that will apply that for us. So very, very unified, very, very great way to scale. You don't have to worry about like having an SRE team of 5 people be the bottleneck for every single ACL change that you want. We didn't really get into ACL changes, but you can definitely manage ACL with Terraform. That's not the best way to do it, but you can, and we do, and sometimes you can't really get around that. So the next concern people usually have is I'm afraid to let other teams use this. I kind of alluded to this in the previous slide. You can use workspaces to get around this, which is nice. But the whole point is that you have PRs, right? So even if SRE still is going to be PRing approving all the PRs and reviewing all the PRs, this is much better than just a Jira ticket or a Slack, like, hey, give me access or I'm going to lose my job, right? You have it documented here, and the idea is you're going to force people to use this pattern instead of hitting you up in Slack and you being like, I have to do it because they said I need it right now. Establish this pattern, and it's like you follow the pattern like everybody else. This is how we do things, right? And it's very easy because if you establish this yourself, right, you have copy and paste examples, and that's the key here for not super technical people or people who just don't really know Terraform and it looks hard, right? If you establish that pattern very early in your infra, you have a ton of copy and paste. They can search, your internal code repo and see, oh, I see this team did it this way. Cool, I'm just going to do that, right? Like access to databases. This is like a BigQuery example. It could be Cloud SQL, Postgres, whatever, right? People can be granted group access or individual access via PR rather than a Jira ticket. You can still couple it with a Jira ticket, but it also takes out that translation layer. SRE doesn't have to like try to figure out what you want. Like you tell them the config explicitly. And as a developer, that's great because often I just want to tell SRE, hey, please just run this code, right? Like you don't want to have to do the human translation layer. So that's nice. Terraform Enterprise looks like this. Well, we're going to do a demo with Terraform Cloud in a second, which is like the baby version. They're very similar. The only difference is you get a registry with here and some other little features and first-class support, which we've never needed because this is like super stable. But basically taking it a layer up, so we did the CLI operations. One step above that is like, I'm going to send it to Jenkins and have Jenkins run Terraform apply. And then a step above that is Terraform's first-class offering, Cloud or Enterprise. And this lets you see and manage the view and applies and even put an additional layer of confirmation on top of that if you want. You can see the state, you can manage the variables in here, workspaces and teams. Like this is the Mac Daddy of infrastructure as code. It's good, but it's expensive, so a lot of people don't use it, which is fine. Second demo, I'm going to show you what that looks like. So I've got this Terraform Cloud over here. Very similar to what I had before, but I'm adding a different bucket in here, and I'm going to add a VM, right? Except I'm not going to run Terraform apply here. I am going to just commit all this stuff up. So adding resources, right? And then I'm going to push this up to my repo. I'll show you what this really looks like. Let me drag my screen over here. Ba-da-ba-ba. So before we see what the run looks like, this is Terraform Cloud. So you have this organization. And this organization would be like your company, right? And then you have different workspaces within. So this can be whatever you want. The way we do things is our workspaces align to projects, and those projects are managed by teams. And typically we'll have 3 workspaces for each project, and our PaaS manages all this for us, right? But we'll have like dev, staging, and prod, and that means that they're all totally unified. They can still pull from the same repo, but depending on the branch that you're on, maybe it will apply it in production and use all the production variables. So I'm going to come into Terraform Self 2023. I've committed something up, so there is now a run, and this run did exactly what Terraform CLI does. It ran a plan, and it says, hey, you want to create a VM, and here's all the configuration for that VM based on your code. And here's the test bucket, same thing, right? And I'm ready to go. Do you want to do it? And you can automate this further. I mean, you can just have it automatically apply. Typically, once you're comfortable and you have a lot of Sentinel policy, which is like checks to make sure you don't do anything stupid, you just get to the point where you just auto-apply everything, and you make sure that the PRs are highly safeguarded by people who know what they're doing. But, you know, baby steps, or if you have like a very, very critical repo, you might want that additional confirmation on here. So now you've got the PR approval flow plus this approval flow. So that's kind of nice. But this is optional. So it's going to do that. It's just running Terraform apply, but in a VM that you don't own. But you can have it run in a VM that you own if that's a concern to you. And you can have Terraform Cloud or Terraform Enterprise just be, you know, kind of like the relay for that. Kind of like BuildKite, if you've used that, same deal. So it's going to create that stuff. It's pretty quick. It's already created it, so that's nice. So we'll pop in here. We'll look at some buckets. So all these buckets now exist. The ones that I created locally, the one that was created before this, and then the one that Terraform Cloud just created. So you can see they're all kind of living in harmony here. And if I go to, let's see if I can do this. It's so hard to see from this angle. If I come to Compute Engine, Virtual Machines, you're going to see that VM that was just created. So rad. Now let's say I want to delete that. You can do that either a couple ways, right? If you're managing it with the CLI, you could just Terraform destroy, or you can just delete these resources. So let's say I'm gonna PR something in, and in fact I'm gonna show you the Git flow for this, so you can see the power. We'll go back to Workspace. This is the repo that it's pulling from. So, I mean, it's just a Git repo, right? I'm going to come in here. I'm going to edit main.tf, and I'm going to delete this stuff. This is how you would tell like a user, like, hey, you know, make a PR, right? And I'm going to just delete all this stuff. I don't need it no more. So, right. Commit changes. You know, typically you'd have them like put in a PR. Cool, please let me do this or I'm going to lose my job, which everybody's going to say, right? You come in SRE, you're like, man, this looks great. One thing before that, it actually runs a Terraform plant for you. So you'll see GitHub automatically will try to run this, and I guess all checks failed here, so I don't know what I did, but GCP credentials, oh, that's funny. What now? I done broke Terraform. If you define variables that you're going to pass in, they have to be received or Terraform's going to break. So you'll see I deleted everything, including the variables in this file. So all I'm going to do is throw that back in here. And this right here is a JSON of the service account that I'm using that allows Terraform to actually control all of this stuff. There are many ways to do auth between Terraform and your cloud providers. This is not a talk on that. So I'm going to just commit this back up in here. Fix. And if we're lucky. No, I've done messed up Git, and I'm on a demo, so I'm not going to fix that. But you can see the idea here is that it's going to do that. Alternatively, I'll show you the same way to do it. Let's say you want to destroy everything in here, right? You can come into your workspaces, you can go into settings, and you can go to destruction and deletion, and you can do a destroy plan. This is the same thing as running Terraform destroy in your CLI. It's going to tear down everything managed by Terraform in here. And I have no idea if this is actually going to work because I've done nuked the repo, which is a very bad sell for Terraform. And this is one of the pitfalls. It is kind of hard when you start doing this stuff. You have to worry about variables and like making sure people don't do stupid things like this, which they will all the time, myself included. Right. Now you can see like Terraform's properly broken. But we can do it in here. In fact, actually, I can do the same thing. Terraform destroy on the CLI, and this is going to destroy everything from this version of Terraform. And now you got two versions of Terraform running against one project, and things are getting confusing, right? This will destroy everything in this TF state, and the other one is living in its own thing. This is a big reason why you don't want people running Terraform locally, like in a CLI, because now state is like, you got to share that. You can put it in an S3 bucket, and a lot of people do that. That's cool. But it gets kind of confusing because nobody can like quickly inspect state, and they get kind of confused if somebody's made a change over here and they try to apply it and somebody else has like already applied something and they don't have the right code. It gets kind of confusing. So again, it's better to like stick with Terraform Cloud and just stick with Terraform Cloud. And as you can see, most importantly, make sure that the plan succeeds. And this is something in Git you can basically, you would have a failure to merge. You would disallow merging if all the checks haven't succeeded, right? This is a new repo, so I didn't do that. So that's another pitfall too. Make sure the plan succeeds before you apply it. So some cool tricks, just a couple things here. Conditional creation, like we'd hinted at earlier. This is, a lot of people don't utilize this. You can use count. You can also use for each, which is like kind of new-ish, and you don't need to worry about that until you know why, as in until you felt the pain of using count. But you can set count to 0 and it just won't create it, but you don't have to worry about like just deleting the entire resource. And this is great in case you have something that like shouldn't exist in dev. Good example is DNS. So let's say I'm going to set DNS, but we don't have like a dev DNS provider. We just have DNS in prod, and that manages all of our dev CNAMEs and stuff, right? So like for our Route 53 stuff, we only do DNS applications in prod. So this is a quick way to have the same code for all 3 branches, but I'm just only going to enable it in prod. You can output straight to Vault. A lot of people don't take good use of this. So let's say I'm generating a service account and I want to generate a key for it, a JSON key. Traditionally, you're going to go into the GCP UI and you're going to export the key, get your JSON, you're going to upload that to Vault manually. It takes time. Better, or like a Redis instance that's maybe password protected. When you generate a resource, an output of that can go straight into another resource. So you can see here, I'm just creating a Vault generic secret. I've got this hooked up to my HashiCorp Vault instance. This could be wherever you want it to be. It doesn't matter. And then I'm just taking the output of this. So the auth string, which is like the API key password for managed Redis instance, and the host, the IP, because when it gets generated, you need to know what IP that is. Baby steps. There's a construct called outputs in Terraform that lets you just inspect that, like if you run it in the UI or if you look at the outputs, you can see the IP. That's cool. But this lets you kind of get all the config somewhere that developers can use it really quickly. So you could send this directly to wherever they store their secrets, and that's cool. Pitfalls, all the stuff that I did earlier where I screwed up, that's a pitfall. Duplicating your config, like I talked about, gets very messy. This is where things start getting very complicated and people start hating Terraform because it's not working the same in prod, right? They're trying to copy and paste code in. SRE or whoever needs to like go pull up the dev config and make sure it matches logically, and there might be dependencies that don't exist in one because they weren't copied over, and that's just terrible. So don't do that unless you absolutely have to. Use variables, use them very generously for everything. In Terraform Cloud, you can manage all the variables very easily. You can set defaults in a file so that when you run everything in dev, similar to like an env, if you were writing an app, it's like, here's all your defaults and everything, so devs don't have to worry about filling out variables to start with. Failing to convince management to buy Terraform Cloud, that's a big one. Definitely convince them to buy Terraform Cloud because it's awesome. A lot of people, again, start getting into the weeds with Terraform, got their state in S3 bucket. Shit gets hard to run. Everybody's like stomping over each other, and you got like 2 people that are running everything for the company. Very bad. So Terraform Cloud is awesome, and use it if you can, but again, it's very expensive. That's it. So I hope you guys learned something. Very, very gentle intro to Terraform, but happy to answer any questions. I got you.
When we do the Terraform input or import, that's only pulling the existing things that were basically pulling it back only into the state file, right? So if I wanted to say bring existing resources, I still need to put in the Terraform template first.
Yeah, exactly. Now there are tools specific to providers that help you do that for you. So like, and obviously there are consultants that will take your money and do that, but definitely there are, for all the big 3 providers, there are tools. I'm sure for vSphere there's something too, because there's not like a ton of things in there, because it's very, it's hypervisor, right? But for GCP, AWS, and Azure, there are definitely tools that you like put in your project, and then you say, I want all these different types of resources, and it generates the big config for you. You're going to have to tweak it and mess with it and get it to work, but it gets like 90% of the heavy work out of the way for you. Yep. Yeah. All right, too.
This is more of a one-on-one reminder. If you're working with local Terraform TF state files, don't commit them to source.
Yes, definitely. And absolutely. I should have put this in the thing. So definitely your git ignore should just don't include anything with Terraform in it. Very bad. You're going to have all the outputs, right? That Redis auth string, that's going to be in state, not good. And if it's in S3, you can encrypt it, and please do. But also if it's not in S3, because it's in Terraform Cloud, it's already encrypted for you. But you can use sensitive secrets to make it even better. Yeah.
Are you going to reject my Terraform plan PR because my equal signs aren't lined up vertically?
Oh man, that's we got a hot debate internally on this one. Oh, you're one of those. So I used to
just use Terraform format.
Yeah. No, I do now. Well, now I mean, all right. So like VS Code, just you can format on save. So I just boom, every time I save it formats, and this is something you should just have as a standard part of your thing, or PyCharm or whatever the hell you use. I'm sure can do it too, but VS Code makes it very easy to do that, but Terraform format is literally Terraform FMT and then whatever file you want, and then it just formats it for you. There are some pipelines that like BuildKite will run that and then commit it back before it goes to Terraform. That's jank. Don't ever do that. But like encourage people to do this, and yes, you can fail the PR. Like formatting is important because it's not like Python where it's like, are we going to use pep8? And I don't like the character width or whatever. There's like 3 things to format. Just format it. Yeah.
The rules seem to be a little fuzzy around where the provider configuration can be sourced from.
Mm-hmm.
That is, if you wanted to provision, say, a Kubernetes cluster and then use with some cloud provider, and use that kubeconfig as input to the provider or the Kubernetes provider,
Right.
then you really need 2 different root modules.
Yeah, you have like this loose dependency that you can't. Yeah. Sorry, finish your question because I got something on that.
Yeah, I'm just wondering, what is the pattern and anti-pattern there? Because everything I've read so far, it just seems kind of fuzzy about when you're allowed to
Mhm.
use the data sources or outputs from the module as input to the provider configuration.
Yeah.
And so I end up needing some kind of parent system that can orchestrate multiple root modules, and then I'm using outputs from one as inputs to the other in order to configure the providers.
Yeah, so there's like, I'd argue there's no standard way to do that, but if you ask any one particular organization, they would say yes, and ours is the standard way and the right way. But typically, the honest answer is you're going to have to run Terraform apply a lot because this is kind of that, and it's kind of something else. Dependencies are hard. You can, in any resource, you can just have a hard dependency on another resource block if you can't make it work. I didn't really talk about this, but if you have two resources and one influences the other, which I think I had on the Redis thing right here. So you see this right here will have a soft dependency on this because it's referencing something that it needs this to resolve first. Terraform is powerful because it does that for you. So all these can be hooked up, right? You're going to have a firewall. You got to apply that somewhere, right? You're going to have policy, firewall, virtual machine, and they're all going to have to be created and resolved in a particular order. Terraform will do that for you if you use these references like this. Alternatively, you could just use strings, right? So you could just like hard code in your firewall name or something, but now it might not be created in the right order, so the VM might fail because you've got a policy attached that hasn't been created yet. So that's there. As far as that specific question with the Kubernetes cluster, it starts getting confusing when you have like these large resources that create and don't have outputs that like cleanly feed in, like they don't have literal output values that are very easy to feed into something else. And providers, whole different game, because providers themselves don't like have an output like this as far as I know. So now you've got to like basically have two different repos. And we do this at Cruise. We have like the infra Terraform, and all of that is in one space, and then all the app level configuration and Kubernetes management is in another one, and that's kind of, you just have to do that.
How does Terraform handle like globally unique resources like S3 buckets? In CFN, it will append a like random string to an S3 bucket. Does Terraform do something similar, or do you have to go and really well define those names before? Then how does that handle across prod and dev if you want to keep things?
Well, I mean, again, when it's created, you get the output, so then you get the UID, and you can feed that into anything else. As far as like between dev and prod, I would need a specific example. Like, what are you trying to link something from one that's not going to exist in the other environment?
Create like an S3 bucket, and I apply a name.
Yeah.
Right, and so if my name's Brian's bucket,
Mm-hmm.
right, there can only be one Brian's bucket. And
Yeah.
all S3.
Yeah, just like GCP, it's globally unique. Yeah.
Right. So how does Terraform do that? Because obviously you want to have like in CFN, it'll apply a random string to the end.
Oh, yeah. Well, in CFN, and that's like a helper. Terraform doesn't care. Like, I mean, that's up to you basically. You can have a data object that generates a UID, and then you could like for each it on bucket. You could recreate this in Terraform, but it's not a first-class feature. It's not like it's going to be like, I'm going to help you out here. That's on you to figure out whatever your resources are going to be named and stuff. So if that's a constraint of S3, you've got to give it some unique ID. Typically, you'll append like a unique organizational name that's very unique that should be good to go. Yeah, and that's what we do. And then you can even use locals. So we talked about vars. You can use vars or locals to put that in a variable, so you can append it to the name for everything very uniformly. Oh, one more. Man, this is a lot more than I thought I'd get.
So you'd said earlier that you wanted an example for why you would want a plan output to a file to use.
Yeah.
So you can kind of do that for crew drift detection, where if someone has made a plan and you want to use it in an apply later, you can diff against that plan output before apply to see if in between when that plan was created and potentially another plan was created that you've gotten detection and drift that occurred either within the plan or outside.
Yeah, you're definitely not using TF Cloud, are you? I can tell. Yeah, that's what's happening when you've got all these incoming and you're like, that plan looks good, but by the time you get around to hacking out Terraform, it's like, oh, shoot, it's changed. Yeah.
Just it is an example.
No, but that's very, very valid. That makes a lot of sense if you have to do it that way, because you get very lucky with Terraform Cloud. You get very linear, like it's 1, 2, 3. All these runs stack up, and you have to apply them all. We don't have to apply them all in order. You can just cancel them all out, and then the next one will apply everything. But yeah, if they're not approved, yeah. Typically, workspaces are the way that like you dev but. Oh, God bless your heart.
Small team.
Yeah. It's fine, but God bless your heart.
Just for state, but for pull requests, I'm using system.
Yeah.
So I show my peer what plan I put. Look, there are no destroys in here. I'm not going to blow up your database.
Yeah.
You can't always tell that by just reading the code.
Yeah.
You want to see some plan output, so I say that.
No, yeah. Before we had Terraform Cloud, it was the same thing in the PR. It'd be like the copy and paste, and you're like, well, I hope that's accurate. And then SRE would be like, well, I'm going to run the plan again just to make sure. So it was kind of like a, yeah. Yeah, that's painful. And Terraform Cloud just gets rid of all that for you. That's the beauty. And then it's in the check in the PR. So if the plan fails or syntax is wrong, you don't even get to merge. Like, it just, all that is gone. So it's worth it. Any managers in the room, it's worth it. I think that might be it. Any stragglers? Anybody not like this? Anybody like Terraform sucks? It's okay. It kind of does. Yeah. There's a learning curve for sure. When you get into an org that has a ton of Terraform, like the first 2 months there, if you've never used it, are going to be painful. I'm sorry.
So, from what I understand, Terraform is primarily for, like, say, the initial resource creation and, or yeah, I guess destruction as well. But, like, say, there's no, like, the Terraform state file. There, like, say, with that, there's no, like, say, ongoing, like, say, health monitoring or anything like that. And if not,
Right.
preferred method for, like, say, okay, if, like,
Making sure nothing changed.
yeah,
Yeah.
like, or say if you have a node with a problem.
Yeah.
Say spinning up a replacement.
No, definitely not a node with a problem. Like Terraform don't care if your resource is healthy. It doesn't know what that means. It just wants to know that it's there, basically. But you get like infrastructure, I don't want to say health checking, but maybe configuration health management, aka has anybody been in there modifying stuff in the UI? If you have a very high volume repo, you're going to get that for free because someone's going to go run a plan and be like, why is it modifying this VM created 8 years ago? And it's like, oh, I see, someone's messed with it in the UI. So you get to surface that, but it's not like, oh, it's on a cron and every day it's going to alert you if Terraform state doesn't match what it should, right? You could easily do that. You just set a cron that just runs a TF plan and sees if anything changes, and that's cool. But it's not going to tell you if your VM's like healthy. Oh yeah, keep it going.
What are your thoughts on using Terraform to manage certain resources that are better treated as deployable, but you want the resource
buddy.
the resource information to stay there? For instance, the best example is a Cloud Function or a Google Secret.
What? Did you set that up for me? So I've got an example of a Cloud Function here I was going to pull up if anybody asked. All right, so this is an anti-pattern that I heavily use. This is my entire team is built off of this. So yeah, you don't. So there's no really good way, as far as I know. If anybody has solved this, please let me know. Terraform is not a full CI/CD platform. It's infrastructure as code, and even Terraform Cloud is still going to help you apply that stuff. But it's not BuildKite, it's not Jenkins. It's not going to help you build code and then put it into something. So that example with Cloud Functions is like you're going to essentially have a zip file, right? And the zip file is going to be deployed by Terraform. And the way that we manage this is we keep the Cloud Function in here, and Terraform bundles it up for you. It detects if any of the files have changed because it creates a zip and it's got the hash. So that part's automated for you. But you kind of lose the fidelity of being able to do operations like on the BuildKite layer or the CI layer. You can't like do code analysis or run tests or anything like that before feeding it into Terraform. You'd have to do that manually and then apply Terraform, which we do. But you can't like have the outputs of BuildKite feed into Terraform, which I'm probably getting a little too complex here. What is your actual question?
So I'm just wondering because you can use Terraform as more of a CI/CD pipeline for things like this.
Yeah.
You are detecting changes and then having Terraform do the actual apply for you. And
Yeah.
if you have the infrastructure stored in Terraform, you have to apply it through Terraform anyway.
Mm-hmm.
But it creates this dependency
Yep.
on how do you allow your developers to
Yeah.
edit the code for the thing that you are now managing, because it's not ephemeral like a VM.
Exactly.
You-
We have this problem now where it's like we've got 80 or 90 Cloud Functions and a team of 5 or 6 and external teams that are kind of hacking on that, and it's like at the end of the day someone's got to hit Terraform apply in the UI. Like I'm too afraid to auto apply because if anything makes it in a master, that code is launched. It's not just the infrastructure has changed, the functionality has changed, and that's something I can't see in a plan. I see the Cloud Functions updated, but it's like, ooh, no, you're using the wrong tool, right? But it's kind of, that's the nature of using Lambdas or Cloud Functions with Terraform. The fix for this is to not use Terraform to necessarily manage those, but use your cloud providers tool. Like GCP has this Git thing, right? Except it doesn't work, right? Like you can't do that if you've got your own GitLab or GitHub instance. Enterprise, it's hard to ship that code over to their Git thing that can trigger their Cloud Function builds. So I would say use Terraform to manage that, except that's not a viable pattern, so there is no answer right now. Get bent. Anything else? All right, cool. Well, thank you. It was great. Nice questions. The end.